Have you ever played The Longing? You play as a shade, and unlock more things to do as time passes while you wait for your king to awaken from his 400-day nap. What about Animal Crossing? Animal Crossing uses this to add flavor text if you've been away from your town for a long time, and Nintendogs use this to create a virtual pet that you have to care for and check in on multiple times throughout the day. And what do these games even have in common? All of these games use a real-time game clock in some way, which is what we'll be making in this video. We'll also touch on how to specify events on certain weekdays, holidays, or seasons. We'll be using the Godot 4.0 file access and time classes to do this. The time class will be used to retrieve the system time in seconds since the Unix epoch. The Unix epoch is the number of seconds that have passed since January 1st, 1970 at midnight, UTC time zone. The file access class is used for reading from and writing to files on the system. Let's get started. First, create a new GD script called timekeeper. Now open the script, and we're going to specify a custom icon above the extend. I found my SVG icons at svgrepo.com. This allows you to edit the thickness and the color of these so you can make them match Godot really easily. Next, we're going to specify a custom class name. Save it. This will allow us to create it from the Create New Node menu. Now I need to specify a few variables for our script to use. File path will be where the timekeeper saves and reads its timestamp files to and from. Timestamp name will be what that timestamp file is called, and the current timestamp is just used to keep track of the current epoch time. Next, we'll specify a set timestamp function. This function will expect a variable to be passed to it, and if it doesn't get that, it'll automatically set it to the Unix time from system, and then it'll write to the timestamp file that we specified here, and convert it into a table and save it as a variable to obfuscate it so it can't be edited using text editors. Next, we'll create a function to do the opposite of that. So we're going to create a get timestamp function, which will read from the timestamp file. Then it'll unobfuscate it and get. You might have noticed we've got an error here. It's because we don't have the convert time function defined yet. We'll define that in a second. Now we'll define that convert time function. This takes seconds and then subtracts it from the current timestamp to get the difference. Seconds is passed to it here. Then after that, it converts it to a dictionary using if statements. Then it returns the time dictionary. We're also going to add this timestamp exists function. This allows us to just call this and check if our timestamp exists already. This can be useful for whatever implementation you're using this for. I forgot to actually say anything about the ready and process functions. We don't need these, so we can just cut them out now. Then we have the fully finished timekeeper script. We're going to save that. Okay, I made this forest bridge scene to show off our timekeeper. There's a skeleton here that's guarding an invisible wall, and we'll make the invisible wall disappear when there's been enough time. My skeleton script, all I've got is this update display function, which changes the text that shows above his head, and then in the process, I've just got the code to update that, and then to check if the player presses page down, which I'm just using because it's convenient. I also added these functions real quick. These aren't necessary for you. These just change the text and play an animation and then a sound for my skeleton, depending on what the skeleton should be saying to you. So to actually start using our timekeeper, we need to add a new node. Then we've got a timekeeper right here. We're going to add that to our skeleton. And then we're going to set the timestamp name to be skeleton. Now in our skeleton script, we'll get the child timekeeper and then check if the timestamp exists. And then if not, we'll set the timestamp and play the animation. So we'll save and run our project real quick. You can walk up to the skeleton. Now he'll tell us he'll be guarding it. And whenever we open our user data folder, we now have a skeleton.timestamp file saved in here. If you open this file in a file editor, it just looks like gibberish and you can't change it. Well, you can, but it corrupts the file and makes it unusable. Now I need to add the logic for if the timestamp does exist, so we'll use an else statement. Then if the timestamp does exist, we will get the timestamp, and then we'll check if it has an hours key in the dictionary. We'll check if the hours key is less than 1. If it is, then the skeleton won't let you through, and if the hours key is over 1, it'll allow you through. We also need to add this little else statement here, so if the timestamp doesn't have hours, it'll tell you you can't go through yet. We'll save and load the game. Now we'll walk up to the skeleton, and it'll tell us it's not time yet. However, this can be cheated. If we go to adjust date and time, change it to not set time automatically, then change it on our own to, let's say, 3, go back, and now he'll let us through. We can fix this by creating a network timekeeper. So what we're going to do is create a new GD script again. This time we're going to inherit from timekeeper, rename it to network timekeeper, and then create. Now we'll set the class name, and then also create a variable called net timestamp. Next we'll delete this process function because we won't be using it, and we'll replace it with a get timestamp override that reads the file timestamp and then uses our HTTP request to send a request to worldtimeapi.org. Then it'll wait for the HTTP request to be completed, and then it'll convert the time into a readable date. Now we'll define that HTTP request completed function we were talking about. This function just checks if the response code is 200, which means it's successful, and then it'll parse the JSON. Then it'll use this convert ASCII to string function, which we'll define in a second, to convert it to a string, and then it'll get the Unix time from the API and set that to the current timestamp. Next, we'll add that convert ASCII to string function, which just takes a table of int values, and then it converts them into a character. Then it adds them all to this result string and then returns that. Our network timekeeper is done now. So we can select our skeleton, then we'll add a new network timekeeper to it. Then we'll replace the old timekeeper with the network timekeeper. We also want to set the timestamp name to be the same. And our get timestamp function is now a coroutine because it has an await inside of it. So any other function that calls it needs to have an await as well. Now whenever we start our game and walk up to the skeleton, he'll ask the server what time it is and not the local computer. Keep in mind this requires an internet connection, so you might want to program functionality to check if the user has internet and account for it. If you have more questions still, check out the Time and FileAccess classes on the docs. You can do a few more things with these classes that I haven't touched on here. As always, if you liked the video, thought it was useful, share it with your friends.
Damn, sour, this shit slap.